Okay, let's examine some features of trapezoids and their individual parts, angles, sides, and diagonals. Okay, a trapezoid is a quadrilateral that has exactly one pair of parallel sides. Okay, so we can't say that all parallelograms are trapezoids because parallelograms have one pair of parallel sides at least, right? Because it's got to be exact. So you can't be both a trapezoid and a parallelogram, if that makes sense. Now, the parallel sides are called the bases, and the other non-parallel sides are called the legs. Fun fact, the leg, you could have a leg that does something like this and points out this way, right? They don't always have to be pointing inward like you see them. That's fine. And let's keep going. They have two pairs of base angles, here and here. They are on either vertex of this top base, so they're a pair of base angles, and then there's another pair of base angles, one at each end of this base, okay? If it's an isosceles trapezoid, then these legs are congruent, and remember these opposite sides are parallel, so what you have here then is we know that the base angles, just like a triangle, the base angles here will be congruent, and also these base angles will be congruent, like this says here, okay? If a quadrilateral is an isosceles trapezoid, which we can see here that it is, then each pair of base angles is congruent, okay? So problem one, finding the angle measures in a trapezoid. CDEF is isosceles. It's an isosceles trapezoid. And we know that this measures 65 degrees, measure of angle C. What is the measures of angles D, E, and F? Well, remember what we know about the angles of an isosceles trapezoid. We know that each pair of base angles is congruent. And because these lines are parallel, we know that same side interior angles are going to be supplementary, summing to 180, okay? So we can use that information and we can say, okay, we know that if they sum to 180, these two, then what is 180 minus this 65? It is 115, so this is 115, and because we know that base angles are congruent in an isosceles trapezoid, then we have this happening, okay? C and F are both 65, and D and E are both 115, okay? Give yours a go and start it back up when you have your answers. Okay, so we're looking at these trapezoids here. The second ring is made up of 20 congruent isosceles trapezoids because we have an isosceles triangle here, okay? What are the measures of the base angles of these trapezoids? Well, if we look at this whole triangle, we can see that there's 20 angles up here making the total 360. So what we do is we say that total 360 divided by 20, because we're splitting the 360 degrees into 20 equal parts, is 18 degrees here for angle 1. Okay, measure of angle 1 is 18 degrees. And since the trapezoid is part of the isosceles triangle, then we have these base angles here and here congruent. Since this is 18, what are these two going to be? So we say, if this is x, this will also be x, so 2x plus 18 equals the 180, and we solve and we find that each of these acute base angles is 81. And remember, since this is a trapezoid, we've got these sides parallel, which means that one of these vertex angles and one of these vertex angles together will be supplementary. So, oops, what do we get there? 99 degrees for y, okay? How about yours? Try this got it problem. What if there was 15 angles meeting at the center instead of 20? What measures would you get then? Okay, restart the video when you have your answers. So here's some features of a trapezoid, if it's an isosceles trapezoid, we're going to get diagonals that are congruent. You can imagine that just like a rectangle, this is symmetrical about this line, right? And so you're going to get those diagonals congruent, okay? We also learned about midsegments, remember? So trapezoids also have midsegments. Midsegment of a trapezoid is the point on each leg that bisects it, okay? So if you connect the midpoints of each of these two legs and we connect them, you get the mid segment of the trapezoid. And since the top and the bottom bases are parallel, this is also going to be parallel as well. And you can remember we had a theorem recently where you have 3 or more parallel lines, and if you cut out equal segments on one transversal, you're going to cut out equal segments on all transversals. So that's kind of illustrating that. But if the quadrilateral is a trapezoid, then the midsegment is parallel to the bases, and the length of the midsegment is half of the sum of the lengths of the bases. So if you wanted to know what the length of MN was, you would add these two bases together, the lengths of their bases, and we would divide by 2, and we would find that length. So if we use that theorem here, then we would say, okay, we have these algebraic expressions that describe the measures of the two bases and of the midsegment. So what is x? Well, remember, we can add these two lengths together and divide by 2, or multiply by 1/2 is the same thing, and it should be equal to the length of the midsegment. So this is what you can set up here, okay? Now you can do what's in the brackets first, okay? Combine those terms, and then take half of this expression, and it's equal to that, solve it out, and you get x equals 3, which is the question that they were asking, okay? Now, oops. How can you check your answer? Remember, it says that the lengths of LM, if you plug in x, the lengths of LM and PN added together, and then divided by 2 should be equal to this when you plug it in, okay? Now, here is your got it problem. Give it a go, solve it out, and start again when you have an answer. Now we're going to look at kites. Kites are quadrilaterals where the consecutive sides, we have 2 pairs of consecutive sides, okay? So the 2 sides that are congruent are consecutive, right next to each other, okay? So 2 pairs of consecutive sides congruent, no opposite sides congruent. If we had consecutive sides congruent and opposite sides congruent, we would have a rhombus, okay? So a kite isn't that type, okay? No pairs of opposite sides congruent. And they have certain properties. If you were to draw the diagonals, you would get the diagonals being perpendicular, just like a rhombus. Kites also have that, perpendicular diagonals. Now here's a proof of that. Recall the perpendicular bisector theorem says that if you are a point on the perpendicular bisector of some segment, like if here's BD, if you drew a line perpendicular to it that bisected it, some point on that, any point that was on that line would be equally distant from the endpoints, okay? So the converse of it says that if the point is equally distant from the endpoints, like A is equally distant from B and D, and C is equally distant from B and D, then those 2 points are on the perpendicular bisector, okay? That's the converse. So since we can take any 2 points and we can connect them to form the line, then the line, or in this case, line segment, that is formed by connecting point A and point C is segment AC. That is the perpendicular bisector, okay? 2 points determine a line. So if we had any 2 points, we found these 2 points individually. If we connected them, we've got that line or that segment that is the perpendicular bisector. Now, by definition, then, those 2 diagonals are going to be perpendicular. An interesting thing here, though, is one of these lines is bisected and the other one isn't. And you should be able to look at this and see, okay? If you go from this vertex to this vertex so that you've got one of each type of side on either part of those triangles, that will be the diagonal that bisects or does the cutting of the other one, splits the other one into two, okay? And so you should keep in mind that one thing does the bisecting, that's the bisector, and the other thing gets bisected, okay? And it's the difference between being the knife or being the thing that's cut by the knife. All right, so we've got quadrilateral DEFG here, and it is a kite, we know that. So what are the measures of angles 1, 2, and 3? Well, because we know that it's a kite, it has certain features, okay? Very specifically, we've got the measure of angle 1 is always going to be 90 because you're hitting it perpendicularly, right? And of course, we know that now two of the angles in a triangle, this is 90, this is 52, so we can calculate out that measure of angle 2 is 38, okay? And it says, because triangle DEF right here is congruent to triangle DGF right here by SSS, side, 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 then we know corresponding parts of congruent triangles are congruent, so the measure of angle 3 is also going to be equal to this angle 52. And this note here just says, how do we know that it's congruent by side, side, side? Well, this side and this side, we already know because it's a kite. This side and this side are going to be congruent, and this side and this side are going to be congruent, so we've already got two of the sides congruent, and then they reflexively share the third side. Now, here's your got it problem. Give it a try. Start it back up when you have an answer. Okay, here's your set of lesson check problems. And just to be helpful when you're working on them, I put this concept summary here, relationships among quadrilaterals. So we start here. We're at a quadrilateral. We know that we're that, okay? If we have no pairs of parallel sides, but we do have consecutive sides congruent, two pairs of consecutive sides congruent, we are a kite. If we have exactly one pair of parallel sides, we are trapezoid. And if we have the legs congruent, after we know that we have parallel sides here and here, if the legs are congruent, then it is an isosceles trapezoid. Now, if you have two pairs of parallel sides, you're a parallelogram. And if those sides are all of equal measure, you're a rhombus. If the angles that are formed, because remember in a parallelogram we have opposite angles congruent, if it turns out all four were congruent and 90 degrees, it would be a rectangle. And if you're both four 90-degree angles and four equal side lengths, then it is a square. And just keep in mind that going here, here, or here is not a given. You might, if some figures might just be quadrilaterals that don't get to be put into any of these more special categories, okay? Anyhow, this is a good little summary of how you can be any one of the special quadrilaterals, okay? Anyhow, write your lesson check answers down and check them when you're done. Good luck.